Alright, Stallion, sorry you couldn't be there, but we'll still take notes. Today we're going to go ahead and learn about prime factorization. Now, a prime number has a factor of 1 and itself. For example, 3 only has 2 factors. It would be 3 times 1. Those are the only way that we can break down the number 3. So therefore, this is a prime number because it has its factor of itself and 1. The opposite of a prime number is a composite number. A whole number that has factors other than 1 and itself is called a composite number. For example, 8. 8 can be concluded as 1 times 8, 2 times 4. So therefore, the factors for 8 include 1, 2, 4, and 8. Now we're going to go ahead and do this little exercise. We need to circle all the prime numbers. And I'm going to go ahead and switch the color. We are going to box all the composite numbers below. Now, a great thing to remember, prime numbers is its number and itself. So therefore, let's go ahead and look at these numbers. Let me change it back to red. 18 has other factors besides 18 in itself, so that is a composite. 5 only includes 5 and 1 for its factors, so that is a prime number. We can't break that down any smaller. 7 only has factors of 7 and 1, so therefore it is a prime number. Let's go ahead and look. 2's factors are only 2 and itself, so it is a prime number. My other prime number would be included with 3, because I could only break that down by 3 and 1. My other prime number would be 11, because I could only break down 11. The only factors that 11 have is 11 in itself, or itself and 1. I apologize. So let's go ahead and look at my composite numbers. Now, if you see any even number besides 2, most likely it's going to be, or it is going to be, a composite number, because it will always have a factor of 2 and something else. So therefore, I could break down 18 by 2, it is even. 20 is even. 22 is even. 16 is even. 30 is even. 26 even. 38 even. 10 even. 6 is even. 14 is even. I apologize, I circled those in blue, but they're actually supposed to be boxed, but they are color-coded. Now let's go ahead and look at 9. What factors do 9 share? Well, of course it has 9 and 1, and it also has 3 times 3, so therefore that is more factors besides itself and 1. Another indicator that you're dealing with a composite number are factors of 5. If a number ends with a 5 or it's 0 and it's not 5 or 0 itself, then it's most likely a factor of 5. So 15 is a factor of 5. 45 is a factor of 5. Let's look at 21. 21, of course, 21 times 1. But also, I can multiply or divide 21 by 3. If I do that, it shares a factor of 7 times 3, so therefore, it is a composite number. Now, I forgot about 19. 19 is a prime number because the only factors that 19 has is 19 and 1, so itself and 1. Now, on to our next vocabulary word, prime factorization. To determine the prime factorization of a number, you must break it down into factors. Continue until all the factors are prime number. That's why we see prime factorization. We're breaking it down into all prime numbers, and we're looking at all of its factors. Prime numbers can be written in exponent form. Now, we did exponent form yesterday. That is whenever we have a term that has a base and an exponent. Let's go ahead and practice this. What is the prime factorization of 30? Now, on the side, I want us to, or on the bottom, we're going to go ahead and write something in our notes. We need to break your number into factors and circle all prime numbers. Now, I wrote it a little big, so be careful. Make sure you include that. So let's go ahead and practice. I have the number 30. I need to break this down into prime numbers. So I'm going to go ahead and make what looks like a tree. 30 is going to be my top, and I'm going to look. What two factors give me 30? Well, it's even, so I could break it down by 2 and 15. I can see that it's also a factor of 10, so I could do 3 and 10. Either way will work. So let's go ahead and try 3 and 10. 3 would be a prime number because I can't break down 3 any further, so I'm going to circle it. 10 is what we call a composite number. It still has factors other than itself in 1. So what factors give me 10? Well, I have 2 and 5. Can I break down 2 anymore? No, it's prime. Can I break down 5? No, it's prime. So the expanded form would be 2 times 3 times 5. The reason why this works is because if we would actually multiply this out, 2 times 3 times 5, well, 2 times 3 is 6. And then 6 times 5 is 30, so it works. But we need to make sure we put in exponent form, considering that we don't have any numbers, base numbers that repeat. The exponent form looks very similar or the same thing as the expanded form. Let's go ahead and try another example. We are going to find the prime factorization of 24. 24 is a number that we began with, and we need to break this down. What two factors multiply by each other give us 24? Well, it's even, so I could do 2 and 12 if we want to think small. I could think a little bigger. I could do 3 and 8. I could do 6 and 4. Either one will work. Go ahead and choose your own. I'm going to think small. I'm going to do 2 and 12. 2 is a prime number, so circle it. We could stop there. 12 has factors of 6 and 2. 6 is not a prime number, so I'm going to break that down even further. 3 and 2. 3 is a prime number, so circle it. 2 is prime, so circle those 2. So let's go ahead and write the expanded form. The expanded form, we're going to write down all our prime factors times each other. 2 times 2 times 2, and then my last number is times 3. Now, I have 2 multiple times, so that's going to be my base. How many times do I multiply 2 by itself? I multiply it by itself 3 times. But I'm not done. I still have this factor times 3, so I'm going to include that in my exponent form. Now is the back. You're going to go ahead and do this by yourself, not with a partner. So I'm going to go ahead and do the first 3, and then you will do the rest by yourself. Now, I'm looking for the prime factorization of 180. So we start off with 180. I need to find out two factors that equal 180. Well, there it's even, so I could do 2. It ends in a 0, so it shares a factor of 5. It also shares a factor of 10. Pretty sure it has multiple other factors, but I'm going to go ahead and choose 18 times 10. 18 is a composite number because I could break that down even further. So 9 times 2 gives me 18. I could still break down 9 by 3 by 3. 3 is prime, so circle it. 2 is prime, so circle it. Now I'm going to deal with the 10. I could break down the 10 by doing 5 times 2. Now I'm going to circle those two because they're prime numbers. Now that all my numbers are prime, I'm going to go ahead and write the expanded form and then the exponent form. Let me change the color so it's not so confusing. I'm going to write down all my prime factors times each other. 2 times 2 times 3 times 3 times 5. Now, I see that 2 is multiplied by itself multiple times, so that's going to be my base. 2 was multiplied twice, so that's my exponent. I'm still multiplying these numbers, and I have 3 2 times, so 3 is going to be my base. And we multiply by itself 2 times, and times 5. So your final answer is 2 squared times 3 squared times 5. Now I'm going to look at the next one. It's asking me, the prime factorization is 2 squared times 5 squared. What number does that describe? So now they give me the exponent form, and I need to solve that. So let's go ahead and start off, right, what we begin with. 3 squared times 5 squared. Now let's go ahead and do my expanded form. So this says 3 times itself 2 times. So I'm going to do 3 times itself 2 times times 5 times itself 2 times. So let's go ahead and solve this. 3 times 3 is 9. Include those 5s. 9 times 5 is 45 times 5. 45 times 5, well 5 times 5 is 25. 5 times 4 is 20, plus 2 is 22. So your final answer will be 225. Okay, last one, and then you're going to go ahead and work on this by yourself. What is the prime factorization of 80? So I'm going to start off with the number 80. I'm going to think, what two factors do 80 have? Well, it's even, so 2. It ends in a 0, so it's 5 and 10 is a factor. I'm going to go ahead and think small. Let's do 2. 2 times what gives me 80? Well, 2 times 40. 2 is a prime number, so circle it. What factors does 40 have? Well, it ends in a 0, so I'm going to go ahead and break it down by 10. 10 times 4. 10 is a composite. Let's break that down further. 2 times 5. 2 is a prime, circle it. 5 is a prime, circle it. 4 I could break down to 2 times 2. So circle those 2's. Let's write the expanded form. I have 2 times 2 times 2 times 2 times 5. That is my expanded form. Now I'm going to do the exponent forms. So I see that I have multiple 2's. So my base is going to have a 2. 2 times itself in this problem 4 times, and still include that 5. So your final answer should be 2 to the 4th power times 5. Okay, you're going to go ahead and do the next 6 problems by yourself. If you have any questions, please ask the sub. He will do his best to help you out. Thank you so much. Hope you'll have a great day. Bye.